we are on the applications of rationals and rational equations and variation. So what we're going to be doing is looking at four types of variation. So the first thing we're going to do, we're not going to really look at equations or applications of them. We're going to look at how we view variation, the different types of variation. Okay, so let me switch up this document here, and so we can be on the same page. So hold on. Okay, so we're ready to go. I rotated it. So in general, there's four types of variation, right? Typically, everybody recognizes direct variation. This is how it's said. Well, first, this type of variation, you're usually just looking at a variable equals the constant k times x. Okay? Inverse, you're looking at division. So our constant k is just a constant. It's a constant of, it's a number in front of the variable. Constant of variation. K is just a constant of variation. So what might this look like in terms of how it's said? In terms of how it says, this equal sign means, it means directly varies. You're going to say directly varies. So y directly varies with x. Means y equals x times some number k. So basically, what is this meaning? It means as one thing increases, another thing increases. So as one thing increases, or it can mean as something decreases, the other decreases. So examples would be like your rate of pay increases as you work more hours. If you think about it, if you work 20 hours, and you get paid constantly at $40 an hour, then you're going to make $100. Now, let's say you worked 80 hours, then 80 times the constant 40, you get $3,200. So as pay increases, hours worked increase. Now the graph of direct variation always goes through 0, 0, and it could look like this. So this is my increase. So this is increasing. So as x increases, y increases. Now in the blue, I'm going to draw a different graph. It's right here. This one, the blue one, is saying as x decreases, y decreases, because it's going the other way. The key thing is, make a note, always goes through 0, 0. Direct variations always go through 0, 0. Now for inverse variations, this is like saying y indirectly varies with x, or inversely. So indirect, so inversely is a better word. Let's just change that to inverse. It's inversely varies with x. Okay, so as one thing increases, the other decreases. As another decreases, the other increases. So a good example of this would be something like that. So my x values are increasing. X increases, y decreases. On the other hand, this one on the left, let me redraw that. This one on the left, y increases. Let's see if I did that right. No. Here we go. Yeah. So, I'm going to come up with some equations after we're done with this, but that's a good example graphically. Okay? So, if I was going to talk about pay varies directly with the number of hours worked, I could say pay equals K times hours. For the amount of ice formed varies indirectly with the temperature, or inversely with temperature. So amount of ice equals K divided by T. And we're going to get to how I'm doing this in a second. But first, let's fill out this rest of this graphic organizer. So for joint variation, you're literally just multiplying. You're multiplying two or more variables. So the variables here would be V, K, L, W. So V jointly varies with L, W, and H. So as one thing increases, two or more other things increase. So examples, volume jointly varies with length, width, and height. So you're multiplying things, okay? Combined variations, you are multiplying and dividing. So you're multiplying one or more things and dividing. So V varies directly right with K, with A, and indirectly varies with T. So if you need me to rewrite that, just writing out this statement here. So V varies directly to the number that's being multiplied. It varies directly. We never use K in this statement. With A, and varies indirectly with T. So that means we're dividing. So let's scroll back up real quick, talk about direct variation. Here we're multiplying K times some number. Here we divide K by some number. So we're going to use this graphic organizer to kind of complete some problems here. So first we're just going to kind of practice some problems. So direct variation, so dV looks like this. Y equals K times X. Indirect variation, Y, K divided by V. Joint variation, Y equals K times A times B. Compound variation, Y equals K times A divided by B. So we have direct variation on top and direct variation on the bottom. So first, Y varies directly with K, X. So I write Y equals K times X. So secondly, it says if Y equals -4 when X equals 2, Find y when x equals -6. So the first thing we need to do is to find k. Find k. I know that when y is -4 and x equals 2, y is -4, x equals 2, what's k? If you divide 2 on both sides, we find that k equals -2. So find y when x is -6. So I know that my formula here is -2x. That means y equals 12 when x is -6. So we're going to try that again. Since y varies inversely with x, so y equals k over x. This time, 40 equals k divided by 16. So I want to find k. K equals 40 times 16. This is 6,400. So now I need to find what x is when y equals -5. So I'm going to erase a little bit. My formula here is 40 let's see. Let me do that over again just real quick. Okay, I see it. So k, we said k equals 6,400, right? So my formula is y equals 6,400 over 16. This is, no, not 16, over x. So here, y equals 6,400 over -5. Using my graphing calculator, I have 6,400 divided by -5. Enter. And I have y equaling -1,280, or 1,280. Next, y varies inversely with x. So y equals k times x, k divided by x. So y, when y is 7, then I don't know what k is, but x is -4. I can find k. K equals 7 times -4, or -28. So my formula is y equals -28 over x. I want to know what y is at that point. Y equals -28 at the point that x equals 5 over 5. Okay. Now, next, y varies directly with x, so y equals k times x. So if y is 15 and x is -18, what is k? Well, if I solve for k, I end up finding out that k equals -5 over 6. So they want me to know what they want to know what y is when x equals 1.6. So -5 over 6 times 1.6 equals, here's my graphing calculator. It's the alpha y equals, enter, -5 over 6 times 1.6, enter. And I get some kind of fraction here, so I'm going to press math. I'm going to go to math, enter, enter. Math, enter, enter to get my fraction, and I get -4/3 equals y. Okay? Now, next we're just going to look at these problems and classify the variation type. So I have one variable equals some constant k. So m equals k times p. This is direct variation. C equals some constant. So equals, basically, you got to be careful. My constant of variation's on the bottom, but the number's on top. So this is like saying C equals negative 1/4 times E. So I'm looking at multiplication. This is direct variation. Number 12, direct variation. Now, one of the other things it told you to do is identify K. K equals negative 5 here. K equals negative 1/4 here. K equals 3. Look at number 7. K equals 9. This is indirect variation. Number 10, K equals 1/2. This is direct variation. Number 13, K equals 1/18. This is a fraction. And this is joint variation because I'm multiplying two letters. Number 8, K equals 4. This is direct variation. Number 11, K equals negative 0.2. This is joint variation. This is compound variation. All right. So it says answer the following questions. As X and Y vary directly, as X decreases, what happens to Y? Well, Y decreases. It does the same thing for direct variation. It's directly varying. If it was inversely or indirectly varying, it's going to do the opposite. So if X and Y are very inversely, as Y increases, what happens to the value of X? It decreases. It does the opposite. That means you're going to answer number 20 and number 21. Next, the graphs classify the following as direct, inverse, or neither. If it goes through 0, 0, and it's straight, this is direct. Okay, here it's inverse. It's going through 0, 0, it's straight, and it's direct. It's not going through 0, 0, and it's not a curve, so it's neither. Lastly, 26, we're going to do one of these problems. So we have to figure out the type of variation that we are working with. So it says the electric current I, I'm going to rewrite this, varies directly as the voltage V. So I varies directly as V. So that means I equals K times V. Now, when 12 volts are applied, the current is 4 amperes. So I want to find, this is voltage, this is my V here, this is my I's, so I is amperes, sorry. So I need to find K first, find K. So plugging it in, I have finding K, 12 volts, so K times 12 equals 4. Now if I want to find K, I need to divide both sides by 12. Simplified, K equals 1/3. Now, I need to know what is the current when 18 volts are applied. So what is I when V equals 18? So I equals, in general, 1/3 times V. This equals 1/3 times 18, which is 6 volts. No, 6 amperes. So I equals 6 amperes. Don't forget the units. I'm going to do another one with you. So it says the volume of the gas, volume varies inversely. So I'm dividing K by pressure P. So I need to find K first. So find K. That means they're going to give me the volume, they're going to give me the pressure, and I'm going to solve for K. So the volume is 200 centimeters cubed equals K divided by 32. So I multiply 32 on both sides. I find out that K equals 6,400. All right, now I took care of this part. So I know that the formula is V equals 6,400 divided by P. They want me to find what is the volume under pressure of 40 kilograms centimeters squared. So that means my volume equals 6,400 divided by P here. At this point, it's 40. So the volume at a pressure of 40 kilograms per centimeter squared is 40. I'm sorry. That's not 40. That's not true. It's actually 160 centimeters cubed. That's my volume. Okay. I'm not going to work through all of 28 or 29, but essentially look for a type of variation to determine the equation that you're using, and you have to give variables for each type. So just looking at number 28, it says the number of kilograms of water in a person's body varies directly as the person's mass. A person with a mass of 90 kg contains 60 kilograms of water. How many kilograms of water are in a person with a mass of 50 kg? So let's look at what we're looking at. We're looking at water weight. So water varies directly. So that means K times the actual weight of the person, which is the mass, M. Okay, so that's my formula in general. I just need to find K. So let's look at a variation of that. So when a person weighs 90 kilograms. So let's say this person weighs 90 kilograms. So 90 times K equals a person's water weight of 60 kilograms. So I divide both sides by 90 and I simplify. Then I know the constant of variation here is 2/3. So that means in general, the water weight of a person is 2/3 of the person's actual weight. So now, how many kilograms of water are in a person with a mass of 50 kilograms? So 2/3 times 50 equals 100/3 kilograms. That's the water weight of this person. Okay. So when you're doing 29 and 30, make sure you figure out the type of variation. Probably underline the things that you're trying to do and talk about, and figure out your formula in general. Then take one version of that variation to find a different version of the variation. Have a great day. Good luck with this. I think we'll have time to touch base about it next class, these last two.